Welcome to Spaceverse, your portal to cosmic adventures. Imagine stumbling across a snowball, resting in the heart of a roaring fire. Sounds impossible, right? But that's exactly what astronomers are saying about one of the most unexpected planets ever discovered, a searing hot Neptune-sized world that somehow has clouds and water vapor in an environment where nothing like that should survive. It's called LTT9779b, or by its official name, Cuancoá, and thanks to the James Webb Space Telescope, we now know it's not just strange, it's groundbreaking. Welcome to Spaceverse, where we explore the cosmos one mystery at a time. Today, we're diving deep into the weird, wonderful, and wildly hot world of Cuancoá, a planet so extreme, it's challenging everything we thought we knew about planetary science. Let's start with the basics. Cuancoá was discovered in 2020 and is located roughly 260 light-years away from Earth. It orbits a star similar to our Sun, but here's the kicker, it completes an orbit in just 19 hours. That means a full year on Cuancoá is not even a single Earth day long. It's incredibly close to its star, so close that its temperature reaches about 3,600 degrees Fahrenheit, or around 2,000 degrees Celsius. To give you a comparison, that's almost hotter than molten lava and approaching the melting point of steel. Under these conditions, you'd expect any kind of atmosphere, especially one with clouds, to be burned off entirely. But Cuancoá defies expectations. This planet falls into a class known as hot Neptunes, but it's not just any hot Neptune. It sits in what astronomers call the hot Neptune desert, a mysterious region where very few Neptune-sized planets exist, especially those in such tight orbits. The reasons are still debated, but generally, planets this close to their stars are either gas giants like hot Jupiters or scorched rocky worlds like super-Earths. A Neptune-sized planet shouldn't be here. It's simply too vulnerable to the intense radiation that close to a star. Graduate student Louis-Philippe Colombi from the University de Montréal described it as finding a planet of this size so close to its host star is like finding a snowball that hasn't melted in a fire. And that's why astronomers are obsessed with studying it. To unravel Cuancoá's secrets, scientists turn to one of the most powerful tools we've ever sent to space, the James Webb Space Telescope, or JWST. Specifically, they use the SOSS mode, or Single Object Slitless Spectroscopy, part of JWST's nearest instrument, the Near Infrared Imager and Slitless Spectrograph. SOSS is particularly well suited for studying exoplanet atmospheres because it captures light in the near-infrared spectrum, light that we can't see with our eyes, but which carries a treasure trove of information about gases, clouds, and temperatures on alien worlds. Using this technique, scientists were able to detect water vapor in Cuancoá's atmosphere, and even more astonishing, found thick clouds on the planet's day side, the hemisphere that always faces the star. Like Earth's moon, Cuancoá is tidally locked. That means one side of the planet is always in daylight, while the other is trapped in permanent night. The day side gets bombarded by relentless heat and radiation, while the night side is shrouded in darkness. In most cases, the day side of such planets becomes so hot that it strips the atmosphere or creates violent storms of metal and rock. But something fascinating happens on Cuancoá. The extreme temperature difference between the day and night sides creates massive atmospheric circulation. On the day side, hot gases rise. On the night side, cooler gases sink. This sets up a convection cycle, a giant planetary heat engine. But that's not all. Because of the planet's spin and the effects of what's called the Coriolis force, this rising and sinking air gets whipped into a strong eastward flowing jet stream that wraps around the planet. This jet moves hot air toward the planet's western limb, the transition zone between day and night, where, strangely enough, temperatures cool just enough for clouds to form. Yes, you heard that right. In a place where temperatures soar to 3,600 degrees Fahrenheit, clouds are forming on part of the day side. That's like having a thunderstorm develop in the middle of a blast furnace. These clouds are especially reflective, and that might be tied to the planet's metal-rich atmosphere. Cuancoá appears to have high atmospheric metallicity, meaning it contains a large number of heavy elements. This promotes the formation of aerosols and reflective cloud particles, which leads to another surprising feature, a very high albedo. Albedo is a fancy term for how much light a planet reflects. Earth has an albedo of about 0.3. Venus, with its thick clouds, reflects about 0.7. Cuancoá's albedo is unusually high for a planet this hot, suggesting that its clouds are reflecting a large portion of the star's light, something that might help the planet cool off, at least slightly, on the cloudier parts of its surface. And the researchers' own words said that this partial coverage of clouds over its day side, which reflects a certain fraction of the stellar flux, probably affects the energy budget of the planet. In simple terms, the clouds are not just passengers, they are active regulators of the planet's climate. They might even help the planet keep its atmosphere longer than expected by bouncing some of the star's energy back into space. The detection of water vapor is equally significant. It confirms that even cloudy exoplanets can be studied by observing the heat they emit. Normally, clouds block light, making it hard to analyze what's happening below. But on Cuancoá, astronomers are beginning to peer through the clouds and unlock what's driving this planet's strange, alien weather. Co-author Bjorn Bennick explains that by modeling LT9779b's atmosphere in detail, we're starting to unlock the processes driving its alien weather patterns. And this is just the beginning. The research team is now using additional observations from the Hubble Space Telescope and the Very Large Telescope in Chile to study Cuancoá's cloud structure in more detail. They hope to learn how these clouds form, how long they last, what they're made of, and how they respond to the planet's heat, winds, and composition. Jake Taylor from the University of Oxford summed it up like we haven't finished piecing together the information about this planet yet. In many ways, Cuancoá is a laboratory, a window into how planets behave in the most extreme environments imaginable. It helps scientists test theories about atmospheric survival, cloud formation, and heat transport, all under conditions no planet in our own solar system comes close to replicating. So what's next? More telescopes, more data, and maybe, one day, even a better understanding of why some planets like Cuancoá survive in the fire while others vanish into it. If nothing else, Cuancoá proves just how weird, wonderful, and unpredictable the universe really is. In a galaxy filled with rules, it's planets like this that remind us there are always exceptions, snowballs that refuse to melt. And that's it. Thanks for joining us on this journey through the strange skies of Cuancoá. If you enjoyed this deep dive, don't forget to like, subscribe, and hit the notification bell so you don't miss our next cosmic adventure. We've got more discoveries, more mysteries, and more mind-blowing science on the way. Until next time, stay curious and keep looking up.